Hello, virtual science students. This is Mr. Steinagel. I just wanted to talk to you about lab reports. So, the lab report accompanies the virtual labs in Edgenuity. There is a lab report guide, which I'm showing right now. I'm actually going to switch over to Adobe because it's a little bit easier to use and see on the video. So if you're in Adobe and this pops up, do you need to fill in this section? You're actually only going to be using the lab report guide to guide you through writing what you did in the virtual lab. So just because you finished the virtual lab doesn't mean that you are done. Now you have to report on what you did. So we'll come back to this first page in the lab report guide at the end. Page 2 starts with the overview and the purpose of the lab report. And the fact that science writing is precise. And so your units have to be included. Whatever decimal place that you're measuring to also has to be included. But there are four sections to your lab. Part 1, which is the introduction. And in the lab report here, the guide talks about it on pages 3 and 4. The second section, second part, procedures and materials. Again, that's talked about on page 4. The third part is data collection, which is talked about on page 5. And then part 4, analysis and conclusions. This is where you talk about the results that you found and how it affected the question from part 1 and your hypothesis. Okay, so let's go right to the introduction. In the introduction, you need to have a title. So it'll be descriptive in a few words, talking about the lab report. So if your virtual lab report was taking measurements, then you would say measurement lab, and then you would put your name there by student Y. And then after your title, you would start with the purpose and the question. So the purpose, there's 3 types of labs: inquiry, discovery, and forensic. Most of the time, you'll be doing either inquiry or discovery. And the question is the reason why you're doing the lab. So the question, if it's the measurements lab, you will have a question of, this lab will be figuring out specific measurements of different objects. Okay? Your hypothesis is also included in the introduction. Once you have your question, then you can put together a hypothesis. The conditions expected in the results. Not that it has to come true or untrue, because a hypothesis isn't a risk or a gamble. It's a scientific statement that you use to pose the question. So again, if we're talking about the measurements lab, a good hypothesis would be measurements can be taken for several different objects. And then at the end, if you've proven that measurements have been taken for several different objects, your hypothesis was accepted. And if you couldn't take measurements for specific objects, your hypothesis was not supported. So again, that all takes place at the end in the analysis and conclusions. And that's really what you need in your introduction, along with your independent and dependent variables. So independent variables, that's the factor that is directly manipulated. That's the one thing in the lab that you can change. So for the measurements lab, there's a block of wood and there's a rock. Those are independent variables. They're not the same. Your dependent variables, that's the measurement. So if you're using a ruler, your dependent variable would be length measurement in centimeters. Okay? Section number 2, procedures. Simply list your materials in this procedures lab, and all of the materials that you used in the virtual lab, once you list them, you can talk a little bit about how you used the centimeter ruler, how you used the graduated cylinder, how you used the electronic mass. So those materials kind of guide you through your procedures. Part 3, your data collection. This is where all of the numbers come into play. If the block of wood was 3.5 centimeters long, you would list the block of wood in your data collection as 3.5 centimeters long. And what I've done is I've downloaded just a report, a lab report that I found online, and it happened to be specific to measurement. And so I just changed the title and then put a student guide as the name. And there's the introduction, purpose, the question, and the summary. I would also add my hypothesis and my independent-dependent variables, which I haven't done yet. The procedures are listed here for you: metric ruler, customary ruler, graduated cylinder, whatever you used. This is where you would put your materials, and then talk about the steps that you use the metric ruler for, that you use distilled water with. Those are part of your procedures. The great thing about finding a template like this is your data table, the tables are already made for you. So as I said, your length of the block of wood, the table's already here. If it's in centimeters, you use the centimeter box. If you're not using inches, you just take this information out, and we're not using it. So the length was 3.5 centimeters. So here you would put 3.5 centimeters, and then you can actually center this in the box so that it reads well. And you can even put an additional space there, and boom, there's your first recorded piece of data. All of the data that you record in the virtual lab needs to go into the data section, the data collection section of your lab report. And then once you've put all your data in, this is where you'll write about the results, what you saw. You can list some of the data points. My block of wood was 3.5 centimeters wide, and then through that you will talk about the other procedures in your analysis. Your conclusion is where you either support or refute your hypothesis. Okay, so the conclusion just simply says, my hypothesis was I will be able to take measures using these specific measuring devices, and I was able to take those measurements. And then we were able to calculate items like density. Those are specific parts of the measurement lab. So I've also put in an example in our Google Classroom of a lab, and I told you that I would go back once we were done with the lab report. I'd go back to page 1. So here's in the lab guide, the last part talks about your analysis and conclusions. You can identify possible sources of error, perhaps why your density didn't come out correctly. This can kind of explain it. It's not right or wrong. It's just a lab and a lab report. Going back up to page 1, before you submit your lab report, use this checklist. Did you title your lab report? Did you state the purpose in the experiment? This is all in Edgenuity, the lab report guide. So when it's time to submit your lab report, now you have something to go by. Use that lab report guide and create your lab reports. This is a very good practice to get used to. It's not going to stop. Every science class that you take from here on out will be requiring a lab report. If you have any other questions, you can contact me through Google Classroom or Remind. Take care.